All right, let's jump right in. Today, we're going after the biggest puzzle in all of physics. I'm talking about the massive quest to unite its two greatest theories, the ones that, right now, just don't get along. And we're going to explore a really fresh take on this, a new framework that tries to solve it all, not with some crazy complicated equation, but with a single incredibly elegant idea. Let's do this.
So let me start by asking you a pretty dramatic question. Are the fundamental laws of our universe broken? I know it sounds like something out of a sci-fi movie, but honestly, at the very heart of modern physics, there is this deep, profound conflict that tells us, yeah, our picture of reality is seriously incomplete.
You see, on one side, you've got general relativity. It's the undisputed champion of the big stuff. Gravity, planets, stars, entire galaxies. It works flawlessly. But then on the other side, you have quantum mechanics, the weird, ghostly rules that run the atomic and subatomic world. It also works flawlessly. They are two of the most successful theories humanity has ever come up with. But here's the kicker. They are completely incompatible. They just can't both be the final word. Okay, so what if the solution isn't to find some even more complicated math to stitch them together? What if the answer has been hiding in plain sight this whole time, in a simple, repeating pattern? That is exactly what this new framework is all about, proposing a single universal symbol to describe, well, everything.
So the first piece of the symbol is delta. I want you to think of delta as the quantum realm of pure potential. It's the wave function, right? This fuzzy, hazy cloud of probabilities, where literally countless possibilities all exist at the exact same time. Before you actually look at a particle, it's not really in any one place. It's kind of everywhere and nowhere. That's delta.
The second piece is Omicron. Now, if delta is the dream of everything that could be, Omicron is the concrete, solid reality that we actually live in and measure. It's the world of definite outcomes, where that particle is right here, not over there. It's the classical world of general relativity, with its solid spacetime and things you can actually point to.
So how in the world do we get from the fuzzy maybe of delta to the definite is of Omicron? That's where the last and maybe most important piece comes in, infinity. Now this symbol isn't just a number here. It's the mediator. It's the engine, the bridge that takes all that quantum potential and transforms it into classical reality. And it does this at the most fundamental level of the universe you can imagine, the Planck scale.
And right here, this is the core principle in action. You have quantum possibilities, or delta, which flow through this transformation engine, infinity, and become the classical, real outcomes of Omicron. It's a fundamental flow from potential to actual. And as we're about to see, this isn't just some neat philosophical idea. It's a pattern that might have been hiding in the math of physics all along.
All right, let's put this idea to the test. This is where it gets really good. We're about to see how this one simple pattern, delta transforms into Omicron through infinity, might just be the secret shared language spoken by both of our warring theories.
Just look at this. It's kind of an aha moment. In quantum mechanics, the wave function, that's our delta, transforms via Planck's constant, that's our infinity engine, into a measurable probability, our Omicron. Now look at general relativity. The distribution of all the energy and matter in the universe, our delta, transforms via Einstein's constant, our infinity engine, into the curvature of spacetime, our Omicron. Do you see it? It is the exact same pattern. This suggests that unification isn't about forcing these theories together. It's about realizing they were just describing two different examples of the same fundamental process.
Okay, so we've got this pattern, this key that seems to fit the locks of both quantum mechanics and general relativity. Now, let's see what doors it can open. Because this framework doesn't just look nice on paper. It might actually solve some of the most profound, mind-bending paradoxes in all of physics.
Let's start right at the beginning, the Big Bang. Our current theories, when you run them backwards, all lead to this singularity, an infinitely small, infinitely dense point where all the laws of physics just break. They give you error messages. It's a cosmic dead end, and it's a huge sign that we're missing something big.
But this delta infinity Omicron idea offers such an elegant way out. It says, you know what? There never was a singularity. Instead of a violent, impossible beginning, the universe just smoothly bounced from a pre-existing quantum state into the expanding cosmos we see today. The infinite crunch is gone, replaced by a finite, gentle transition. And just like that, physics is saved.
All right, next up, the black hole information paradox. This one is a real heavyweight fight. General relativity says if something falls into a black hole, it's gone. Poof, forever. But quantum mechanics has this one sacred, unbreakable rule. Information can never, ever be destroyed. It's a head-on collision between our two best theories. Somebody has to be wrong.
So what's the solution here? Well, this framework suggests the information isn't destroyed at all. It's actually preserved, stored safely in quantum corrections near the black hole's core, and then it's gradually, slowly released back out into the universe. In this picture, a black hole isn't some cosmic trash incinerator. It's more like a quantum safe, holding on to the universe's data until it can be returned.
And this table here really sums up the shift in thinking. Where the old view gave us impossible things like singularities and assumed spacetime was perfectly smooth, this new view replaces them. We get a quantum bounce instead of a bang, and a quantum foam, a churning, energetic texture to reality itself at the tiniest scales. It's not just a tweak, it's a complete rewrite of our cosmic biography.
Now, I know what some of you might be thinking. This all sounds like a really neat story, a cool bit of philosophy, but is it actual science? And the most exciting part about this framework is that the answer is yes. It's not just an idea. It makes real, concrete, testable predictions that future experiments could actually go out and look for.
Now, here's just a handful of those predictions. And don't worry about the complex terms. The big idea is simple. This framework makes specific claims about how the universe should behave that we can either prove or disprove. It predicts space-time should have a kind of foamy texture if you could zoom in far enough. It predicts we might see strange little echoes in the gravitational waves from colliding black holes. These aren't just abstract ideas, they're clues we can actively search for. And it all comes together in this one equation. Now don't get scared by all the symbols, let's just talk about what it means. Think of it like the ultimate recipe for the universe. On the right, you have all the quantum possibilities, and all the possible shapes of spacetime, our two deltas. And that T in the middle, that's the grand transformation, our infinity engine, powered by the fundamental constants of nature. It's basically saying the entire state of the universe is just one single, unified process unfolding.
And that brings us to one last, really provocative thought. If this framework, or something like it, is correct, then the universe isn't just a collection of static things. It's a single, continuous process, a transformation, from a sea of quantum potential into the cosmic reality we are all a part of. So the final question isn't just, what is the universe? But maybe, what are we all transforming into?